Alright, here we are for the most difficult thing that you're going to be doing on the Chapter 3 exam, the limiting reactant problem. Ta-da! Okay, so here it is. A 10.6 gram of copper reacts with 3.83 grams of sulfur to form copper 2 sulfide. Excuse me, copper sulfide. Copper 1 sulfide, not copper 2 sulfide. How many grams of the product, copper 1 sulfide, will be formed? So this is our limiting reagent problem. First off, we need to balance our chemical equation. Well, we see we have one copper on this side, two coppers on this side. So we obviously need a 2 here. We have one sulfur on this side, one sulfur on this side. We are now balanced. Now let's go ahead and go through the steps to figure out which one is the limiting reagent. So starting with 10.6 grams of copper and 3.83 grams of sulfur. There's one other thing that you might want to do at this point, when you're doing these calculations, that is to actually calculate the molar mass of copper 1 sulfide. But for this this particular problem, I'm not going to quite yet. Okay, so let's just go ahead and start with what we got. So starting with the 10.6 grams of copper, we're going to convert that into moles of copper. How do we do that, you might ask? Well, we're going to have to go to the periodic table. So pulling up my periodic table, which I have shut down again. We're going to have to go to the periodic table. So here it is. Alright, we see that copper is right here on the periodic table. It's 63.546 grams per mole. So we want grams on the bottom, obviously. We want moles on the top. And we put 63. What was it? 546? 546. 546 grams per 1 mole. Then we want to convert from grams of copper from moles of copper into moles of copper 2 sulfide. So we need another conversion here. We do mole of Cu on the bottom to cancel with the moles of Cu here, and then mole of Cu2S. Now what are the numbers that we want here? Well, we get that again from the balanced chemical equation. Remember, when you're converting from moles of one thing to moles of another thing, you have to use the balanced chemical equation. So we see that for every 2 moles of copper, we're getting 1 mole of copper 2 sulfide, or copper 1 sulfide, and that will give us the number of moles of copper 1 sulfide. Here we go. I'm going to go ahead and bring up the calculator to put it in. Oh, there it is. All right. So 10.6 times 1 times 1, so we're not even going to put that in there, divided by 63.5 divided by 2. And the moles would be 0.0835. So 0.0835 moles of copper 1 sulfide. Going to starting with the sulfur, we're going to do the same type of problem. First, we need the molar mass or atomic mass for sulfur. Going back to the periodic table, we see sulfur is 32.065. So 32.065 grams per 1 mole. Then we got to convert from sulfur to the copper 1 sulfide. So we see that it's a 1-to-1 ratio, so 1 mole of sulfur for 1 mole of copper 1 sulfide. Alright, now we're going to end up, we need to pull up the calculator again. Oh no. There it is. Alright. Okay, here we go. Got everything up. So, 3.83 divided by 32.065. So it's going to give us 0.119. So 0.119 mole of copper 2 sulfide. So now that we have that, we can see which one is our limiting reagent. It is not this. This is not our limiting reagent. This is a product, right? It is actually the copper, and so this is our limiting reagent. The copper is our limiting reagent because it's producing less of our product. Now let's go ahead and continue on this discussion and figure out how much of our excess reagent we have. So starting with the actual amount of product we'll form, which is this right here. So 0.0835 mole of copper 1 sulfide. We're going to convert that back into the number of moles of our excess reagent that we have. So this be 1S 1Cu2S, and then so it'll give us the same number, 0.0835 mole of Cu2S. So this is how much of sulfur, not Cu2S. So this is how many moles of sulfur we actually used. If we look at this, this is how many. How much of the oh, now we have to see how much sulfur we actually had on a molar basis. So 3.83 grams of sulfur times 1 mole divided by 32.065 grams equals 0.119 mole of sulfur. This is how much sulfur we actually started with. So if we subtract these two together, subtract from this much we used, 0.0835 mole of sulfur, that will give us our excess. So going back to our calculator, so 0.119 minus 0.0835, we will end up with 0.0355, so 0.0355 mole of sulfur excess. If we wanted to, we could convert that back into grams of sulfur just by using the molar mass of sulfur again, this 32.065, but this is our excess sulfur. Now let's do one more thing with this number. We have the moles of copper 1 sulfide that will actually form. So on the next slide, we see that we actually have grams of copper 2 sulfide that were actually made. So this right here is an experimental value. This is how much would be that was weighed afterwards. This back here is what we call a theoretical yield. This is how much we should be making with this much reactant. These two reactants added together should make this much, but in reality it only made that much. So it's asking us to calculate a theoretically or a percent yield, and it's the actual yield, that's this, divided by the theoretical yield. Now notice we're not in the same units. We need to convert this back into grams of copper 2 sulfide. Excuse me, copper 1 sulfide. So starting over here, we have 0.119 grams of Cu2S. Need the molar mass for that, so go to our periodic table. Copper is again 63.546. Sulfur is 32.065. So 63.546 grams per mole, 32.065 what is it, 32.065 grams per mole. But there are 2 coppers here, so we need to multiply that by 2. So times 2. So going to here, 63.546 times 2 plus 32.065 is 159.157. So 159.157 grams per mole. Now we might have a few extra sig figs, but that'll be okay. We'll keep them in there for right now. So if we're going to convert this, this is not moles, grams, that's moles. We're going to convert this from moles of copper 2 sulfide to grams of copper 2 sulfide. We got to put 159.157 grams per 1 mole. So we divide here by here, pull our calculator back up. So 0.119 times 159.157. So we should have made 18.9 grams, 18.9 grams of copper to sulfur. So the percent yield is the actual yield, that's this yield, divided by the theoretical yield. So we see that we put 10.3 grams over 18.9 grams times 100%. Bring our calculator back up. 10.3 divided by 18.9 times 100. And so very sad, we only had 54.4 or 54.5% yield. Now what happened to the rest of that? It could have been lost while you were precipitating stuff out. It could have been lost in all kinds of different ways. Maybe the reaction didn't go all the way to completion for some odd reason. It was quenched. Never know why we don't get 100% yield, but it oftentimes the case that the 100% yield is not reached.